Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to continue what we started last video. We were talking about the ionic compounds and the ionic bondings. Before we start this video, if you guys did not watch the previous video about the ion formation, I recommend you to go and watch it because the information are linked to each other. Today we're going to focus on the ionic bond, and our objectives are to understand how the ionic bonds are formed and how the ions are arranged in an ionic compound, as well as how to conclude the strength of the ionic compounds based on its physical properties. I also look at this image on Google. One atom, it was asking, or it was saying, I need one electron to complete the octet, and the other atom answered, I have one extra electron, you can have it. So by the end of this lesson, you're going to be able to understand this image. All right, so let's get started. What is the ionic bond? The ionic bond is the electrostatic force that holds oppositely charged particles together in the ionic compound. So we need to understand what is the oppositely charged particles. It means that one of them should be positive and the other one should be negative, oppositely charged particles. And the force between them is an electrostatic force. We also have another definition about the binary ionic compound, which contains only two elements, and they should be different. One of them should be a metallic cation, that is the positive ion, and the other one is a non-metallic ion, which is the anion, that is the negatively charged particle. So basically, the ionic bond always it consists between a metal plus non-metal. All right, this is the periodic table. All the blue elements are metals and all the yellow elements are non-metal. Those red elements are metalloids. They have the properties between the metals and the non-metals. We're going to study this in details when we study the periodic table. But for now, all those elements in the blue ones are metals, which form always positive ions, which are cations, and the nonmetals in the yellow color, they always form the anions. It means negatively charged particles. All right, compound formation and the charges. Look at this diagram here. You will see that the sodium atom initially, it has this extra electron, one valence electron in its outer shell, and according to the octet rule it needs to get rid of this electron to have 8 electrons in the outer shell to be more stable. Also the fluorine, it has, if you check before the transfer of this electron, initially it has 1 2 3 4 5 6 and 7. According to the octet rule it needs to have 8 electrons in the outer shell, so it requires 1 electron. So what happened is, if we write the electron configuration of the sodium with 11 electrons, it's going to be 2 8 and 1. We have only one valence electron. We need to get rid of this valence electron. So after losing this valence electron, it will become Na positive, which is the cation, as well as the fluorine with 9 electrons, 9 electrons for the fluorine, the atomic number. That means the electron configuration is 2 and 7. So we have 7 valence electrons. To implement the octet rule, we need 8 valence electrons, so it's going to gain 1 electron. And it will become F negative. Now, if we go back to the definition of the ionic bond, it's an electrostatic force between oppositely charged particles. And those are the oppositely charged particles. As you can see, the sodium will become Na positive, and the fluoride or the fluorine will become F negative. And then the electrostatic force between the oppositely charged ions. As simple as this. This is the ionic bond. Let's have this example. For example, if you're talking about the magnesium Mg, the atom, it has 12 electrons from the periodic table. So the electron configuration is 2, 8, and 2. According to the octet rule, we need to get rid of these 2 electrons. So I'm going to lose 2 electrons to become Mg positive 2. And we have the chlorine atom, Cl, from the periodic table. It has 19 electrons, so it's going to be 2, 8, and 7. It's going to gain 1 electron to become Cl negative 1. Now, to form the ionic compound, all compounds, they must be neutral. It means that they don't have any charge on them. The overall charge should be 0. But if I have Mg, for example, with positive 2, that means I need 2 chlorine or chloride ion in order to make it balance, or in order to make the overall charge 0. So these are the valence electrons. The first electron will be lost to the first chlorine atom, and the second electron will be lost to the second chlorine atom. So it's going to be, we need 2 Cl negative in order to make the compound neutral. So Cl negative and another Cl negative. Here we have negative. All right, let's check it with the sulfur. Sulfur, it has 1, 2, 3, 4, 5, 6 valence electrons. Mg has 2 valence electrons. Sulfur needs 2 electrons. Mg needs to get rid of or to lose 2 electrons. So these 2 electrons will be lost to the sulfur like this. That means Mg will be positive 2, and the sulfur will be negative 2. So the overall charge here is 0. So the compound should be MgS. But the compound here should be MgCl2. In another video, we're going to find a rule or figure out a rule how to write the ionic compounds. But always, as you can see, the positive is always written first on the left hand, and then the negative particle should be written on the right hand. Let's check for the Mg PB or MgP phosphorus. So also Mg needs to get rid of these 2 electrons, and the Pb, because it has 1, 2, 3, 4, 5 valence electrons, we need to gain 3 electrons. But also only we have 2 electrons for the Mg. So how can we do it? Mg will lose 2 electrons, so it will become positive 2. And P will gain 3 electrons, so it will become negative 3. So let's check now. The rule is I'm going to write only the number of the charge of the magnesium underneath it. So it's going to be number 2. And the P, I'm going to write number 3 without the charges. So Mg will take number 3 in the compound, and P will take number 2 in the compound. As simple as this. And the compound should be Mg3P2. And we need to have the simplest ratio. For example, if we have here 6 and 3, so if you divide it by 2, it's going to be 3 and 2. Let's implement this on the first example about MgCl. So Mg here, I have Mg positive 2, and the Cl I have negative 1 only, because it will gain only 1 electron. So I'm going to write it 2, 1, Mg will take 2, and Cl sorry, Mg will take 1 and Cl will take 2. So the compound is MgCl2. We will have some example problems to understand how we use this rule. Example problems. Explain how the ionic compound forms from these elements. The first one, sodium and nitrogen. Sodium, first step is to write the electron configuration. And from the periodic table, the atomic number of the sodium is 11. So it's going to be 2, 8, and 1. The valence electrons are 1. The sodium atom will lose 1 electron to become 2 and 8. And this is the sodium cation, Na positive 1. For the nitrogen, also from the periodic table, we have 7 atomic numbers, so 7 electrons. So the electron configuration is 2 and 5. And we have 5 valence electrons. To apply the octet rule or to implement the octet rule to be more stable, we need to gain 3 electrons in order to make them 8. So the electron configuration will be 2 and 8. And the charge of the nitrogen ion is going to be N negative 3. Now, apply this rule. N is the Na is the positive, so it's always on the left hand, positive 1. Nitrogen is the negative, so it's always on the right hand. I'm going to write the number underneath it, so it's going to be 1 here, 3 here. Na will take 3 and nitrogen will take 1. So the compound should be Na3N. Na is a metal, nitrogen is a non-metal, so it's an ionic compound. This is the Na and this is the N. Another example, I want you guys to pause the video and try to solve it for B. All right, for B, aluminum, Al, from the periodic table, it has atomic number of 13, and then the electron configuration is 2, 8, and 3. We have 3 valence electrons, so it's going to lose 3 electrons. And the aluminum charge will be Al positive 3. We have the sulfur, and the sulfur atomic number is 16. So the electron configuration is 2, 8, and 6. That is 6 valence electrons. I need to gain 2 electrons. And the sulfur, after gaining 2 electrons, it will become an anion with negative 2 charge. Applying this rule, Al positive 3, sulfur negative 2, 3 underneath the aluminum, 2 underneath the sulfur, so Al2S3. So the compound should be Al2S3. All right, now a new keyword, it's called the crystal lattice. The crystal lattice is the three-dimensional geometric arrangement of the negatively charged particles in the ionic compound. Actually, this one is by mistake. It's the oppositely charged particles. That means the negative and the positive. So again, it's the three-dimensional geometric arrangement in the 3D of the oppositely charged particles in the ionic compound. For example, if we take a look at the table salt, this is the table salt, and it consists of the sodium ion and the chloride ion. So the table salt basically is NaCl. And this is the crystal lattice of NaCl. The yellow one, the big ion, is the chloride ion, and the white ion is the sodium ion. This is the sodium chloride crystal. Now, The crystal energy, it depends on two factors. The first factor is the size of the ions, and it means that the smaller the ions are, the higher the energy of the crystal is, and as well as the charge of the ions. Some of the ions, as you see here, some of them they have positive 1 and negative 3, some of them positive 3 and negative 2. That these ions, they have more charge than this ion. And also from the first example here, NaF, we have only positive 1 and negative 1. So the crystal lattice, or the lattice energy, it depends on two factors. The size of the ions, the smaller the ions are, the higher the energy is. And the charge of the ions, the more charge the ions have, the higher the energy is. If you take a look at this table, you will find, for example, Ki, K is positive 1 and I is negative 1. And also the I ion is very big ion. And also the potassium ion is a big ion. So they have big size, not small, and they have low charge, not big. So that's why the lattice energy is only 808 kilojoule per mole. But if you check, for example, about NaF, sorry, this is for Kf, this is for the Ki. If you check, for example, for the MgO, because Mg is positive 2, not positive 1, and the oxygen is also negative 2, so it's going to be Mg2O2. But as I told you, we're going to take the simplest ratio. So we divide by 2, we divide by 2, so the compound should be MgO. And this compound has a very big lattice energy because Mg has positive 2 and the oxygen has positive 1. All right. Let's talk now about the physical properties, and we finish today's lesson. The physical properties of the ionic compounds, they have very high melting points and boiling points. And the reason behind this is that they have very strong attraction between the ions. So they have high melting and boiling point because the strength between the ions is so big. Number two, they cannot conduct electricity when they are solids. Like table salt, for example, if you try to connect it with electricity, it will never conduct electricity when it's solid because the ions, the negative and positive ions, they cannot move freely. Whereas when they are dissolved in water or you melt them, they can conduct electricity because after they are dissolved, those ions are, or they can move freely and they can conduct electricity. Number four, they are very hard, the ionic compounds, rigid and brittle solids because of the strong attraction. This is O, because of the strong attraction between the ions. And number five, the crystal breaks if external force with enough energy is applied. If you apply an external force, this crystal, for example, the table salt, it will break easily because of the repositioning of the ions. As you can see here, this is the crystal lattice without the external force. Positive, negative, etc. So every positive is attracted to the oppositely charged particle. But when you apply an external force, what happens is now the positive will be positioned to the another positive ion. So positive and positive, they will repel each other, and this is the result. The lattice will break. So what do we need to take from this lesson? Ionic bond, it forms between two oppositely charged particles, a metal and non-metal. The non-metals are only those elements, and the metals are the blue elements. The formation of the ionic bond is very simple. One atom will lose electron, which is gained by another atom, and it's forming ions. Now these ions, they have oppositely charged, and they can be attached to each other. We took two examples here about the Mg with sulfur and Mg with phosphorus. We solved two example problems about the sodium and the nitrogen, aluminum and the sulfur. Now, what I recommend you guys is to look at the periodic table and try to do any ionic bond between group number 1 and 2 metals, and try to do it with group number 15, 16, and 17 nonmetals. So any elements you can choose. For example, potassium and fluorine. We can do beryllium and sulfur. We can do calcium and oxygen, then calcium and phosphorus, etc. Just practice about this. I hope you guys learned something new. Have a nice day. Bye bye.